Okay, so on to part six. So part six is going to be mainly about correlation between two groups expressed by a linear model. So in the previous parts, we were kind of just looking at two groups being just correlated, seeing if there is the relationship or not. And in this part, it's going to be that plus expressing it through a linear model. So this picture or diagram kind of shows what this part's going to be about. And the main takeaway is that you're going to have two groups. So one's going to be a y variable and one's going to be the x variable, right? And so the y is basically expressed by the x. So you can think of it as there being a y group and an x group, right? So yeah, we'll kind of get into that. And in this part, there's going to be two types of questions generally. There's going to be a question with data and a question with no data, right? So starting with the question with data, um, just a side note, you can see the top right, the different types of hypotheses. The left-tailed is going to be your negative correlation, your right-tailed is going to be your positive correlation, and your two-tailed is going to be your uh, just general correlation, right? So if you're asked if there's a positive correlation between the two groups, then that's a right-tailed. And if you're asked, is there a correlation, that's just two-tailed. So if it doesn't specify if it's positive or negative, it's just two-tailed, okay? And then, yep, so in a question with data, you're going to be given a CSV. So essentially to solve the question, it's pretty simple. First, you're going to use the linear model function, right? So first you're going to just name your linear model. I just used ABC. And just do equals lm of your y group tilde x group, comma, data equals the name of your data, so whatever the CSV is called. All right. And so to kind of explain what the y group and x group is, essentially the y group is explained by the x group. So let's say you have group 1 and group 2, right? If your question's asking, can group 2 be expressed as a linear function of group 1, right? So group 2 is the one being expressed. Then group 2 is going to be the y group. And then obviously group 1 is going to be the x group. So whatever group is being expressed is going to be the y group, if that makes sense. I mean, it's pretty simple once you're given a question, right? And then you name your linear model because to get the actual data, you got to do summary of whatever your linear model is called, okay? And so once you do that, you'll pretty much get all the data you need. You can solve most questions just by doing this. However, sometimes you're going to be asked like a test statistic, right? So to get that, you'll just be getting the slope, which is beta 1, and in your data, it's going to be the estimate of the intercept, right? And it's going to be minus c, which is essentially, if you look at the hypothesis at the top right, you can see your c is going to be 0. It's whatever the constant value you're using is in your hypothesis. And I think it's going to always be 0. I mean, I don't think I've ever come across a question that wasn't 0, but if it isn't 0, just remember it's your slope minus c, right? And then you divide that by your slope standard error, which you get in your data from your linear model. And then for the p-value, you're just going to use the pt function with your t statistic, your degrees of freedom, and then your lower equals f. And then if you're asked for a confidence interval, you use the confint function, I think that's how you call it. And then, yeah, you just use your linear model, comma, and then level equals your confidence level. And then you'll occasionally be asked to find the confidence interval for a given x value. And so you'll call it x star. X star is essentially the given x value, right? So if you're asked this, you'll just use the predict function, right? So you go predict brackets your linear model, comma, data.frame, your x group equals the given value of x, so your x star, and then just comma your interval, which is your interval equals confidence in brackets, which is important, and then your comma your actual confidence level, so level equals 1 minus your alpha. So that's how you do a confidence interval for a given x value. And I mean, you'll know because the question literally will say, this is the this is a x value. Find the confidence interval, blah blah. I mean, you'll know once you see the question. But you'll also occasionally be given a prediction interval for a given x value, and it's the same sort of formula. The main difference is that you'll be putting prediction in brackets instead of confidence, and then the rest is just the same though. Alright, so pretty easy, yeah. But now onto the no data question. Things get a bit, I don't know, harder, I should say. So a no data question is basically a question where you don't have a file or a CSV to download. You'll still be given data, but it'll be limited, so not to the extent of a question with data. So just to show what data you'll be given, um, this is the data you will have in a question with data. So if you have a CSV, you could download it and you can get all this data out, right? In a question with no data, well, on a side note, just the bottom part is an ANOVA table, and you'll be kind of using this in parts 7 and 8 more often, but in any case, in a question with no data, you'll be given pretty much these parts, just to make it easier to see this. Depending on your question, you might be given a different format, so you might be given the totals, and if that's the case, then you can just simply get the total minus whatever sum square you have, and then that's the other sum square. And you'll also be given the sample size, so n, and your significance level, so alpha. And just a little, I guess, tidbit. To get the degrees of freedom for your X group, or your regression in this case, and then your residual error, or residuals for short, basically your regression will always have a degree of freedom of 1, right? And then your residual error will have a degree of freedom of just n minus 2, right? So let's say the total degrees of freedom you get in a question is 100, right? Well, if it's blank, then you know that your X group, or your regression degrees of freedom, is just going to be 1. And then so by process of elimination, your residuals degrees of freedom is going to be n minus 2, so 100 minus 2, which is 98. Okay, so just as an example. And then, yeah, we'll kind of be keeping this data just to show how you would input your data into certain equations, right? So just to start off, for your linear model equation, right, your beta 0, right, so your intercept is just going to be the estimate uh, for your X group, right? Or sorry, not for your X group, for your intercepts, obviously. And then your B1, so your slope is going to be the estimate of your X group in this case, right? Pretty simple. And actually, I should have mentioned before, this E variable is pretty much, you don't have to worry about that. Yeah, I've never had to do anything with this. So yeah, just keep that in mind. Technically, the equation is going to look like this, but the E is just going to end up as nothing. So yeah, just keep that in mind. And then if you're asked for your R squared, you basically have to use the SSR, which is the sum squared of the regression, so the X group, divided by the SSR again, plus the SSE, which is your sum squared of the residual error. Fuck, sorry, yo, I'm tired. So yeah, it's a bit confusing because these names are kind of shortened, but your SSR is whatever the top sum squared is, and then your SSE is whatever the sum squared at the bottom is, right? And then, yeah, you can see kind of how the data is inputted, so it should look like that, right? And then next, if you're asked for the test statistic, you just use your slope minus your C, so your constant variable, right? And then divided by your slope standard error. So you'll be using these pieces of data and it'll look something like that, right? And then again, to get the p-value, you just do pt, test statistic, degrees of freedom, lower equals f, right? Now another thing that you need to worry about is the f statistic, right? So previously in the question with data, you didn't need to do any formulas because when you do the linear model, it'll just tell you what the f statistic and the f p-value is, right? So in this case, you actually have to do it yourself, right? So again, you're going to use the SSR divided by the degrees of freedom of your regression, and then divided by your SSE over the degrees of freedom of the residual error, right? And so this is kind of a important little bit, I guess, is because your SSR is divided by the degrees of freedom of the regression, which remember is 1, right? So really you're just going to be doing SSR divided by SSE over the degrees of freedom, but technically this is how the equation is supposed to look, right? And then for the f p-value, it's a little different. You're going to use the pf function instead of the pt function. Then you're just going to input your f statistic, your degrees of freedom for your x group, and then your degrees of freedom for your residual error, and then lower equals f, right? Okay. And then lastly, if you're asked for a confidence interval, this is kind of how you solve it. So for the lower bound, it's just your slope plus the qt of your alpha divided by 2 times the slope standard error. And then it's the same for the upper bound, except it's just 1 minus the alpha divided by 2, right? So generally, not too much more difficult than a question with data. However, we're still missing 2 extra parts that you might be asked in a question with no data, right? So these questions you might be asked are questions that ask confidence or prediction interval for a given x value, right? So if you're given like an x value of, let's say, I don't know, 100, right? You're going to be asked to find a confidence interval or prediction interval of y given that x value of 100 or whatever, right? And you'll know when you're asked this question because you'll be given extra data, right? So the first bit of data you'll be getting is the sum of your x group, right? So yeah, that's self-explanatory. It's essentially just the sum of all the values of your x group. And then the second part of your data is going to be the squared sum value, right? And basically what it is just the if your X group has 100 values, right? 100 individual separate values, the square sum value is the square of all those values added together, right? So it's not the sum squared, it's the first value squared plus the second value squared all the way to the 100, right? So the squared sum. At least that's what I call it. But anyway, so yeah, you'll be given those extra pieces of data, and the equation to solve the confidence interval for the given x value is this right here. Wow, so nice. Not complicated at all, right? So yeah, to make it easier, it's basically the equation is grouped into 4 different parts, right? So this first part right here is essentially your u hat of y, and it's basically just the mean response of y. And yeah, the reason why it's a mu hat is because technically you're using a subpopulation, so this confidence interval is not a full representation of the whole population. So yeah, I don't know. That's why it's the mu hat. Then you have this part here, which is just the reduction region, which is pretty simple. And then the next part is just your standard deviation of the regression, which is just square root of your mean squared of the residual error, right? And then the final part is just your standard error of mu hat y, right? And so yeah, there you go. You just plug in all your data and then boom, easy, right? Yeah, there you go. Yeah, no, don't worry, I have our formula as well. It's right here. Now, that being said, it's still pretty uh, bad. It's hard to read, I guess, and if you make one mistake, then your whole formula is kind of messed up. So that's why I kind of brought up the actual uh, hand-done formula for this question, just because you can group up these certain parts and not have to do it all at the same time, right? So again, if you wanted to, yeah, solve the confidence interval for a given x value, instead of just inputting all these data pieces at once, right, you can just split it up. So you can do first part, second part, third part, fourth part, just name those as separate values, and then you can add them up together, right? So I don't know if that makes it easy for you or helps out, but I just thought I would add that in there because this equation's pretty bad, right? And then again for the prediction interval for a given x value, it's pretty much identical. The only difference is if you look at the fourth part, you're going to be adding a 1 plus in the square root at the beginning, right? So if you see the confidence interval, it's just 1 divided by n, blah, blah, blah. In the prediction interval, it's going to be 1 plus 1 divided by n, blah, 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 right? That's the main difference. So yeah, just make sure you add that if you're asked for a prediction interval. And if not, if you're just asked for confidence, then yeah, you don't need to add that 1 plus. Okay. And now, again, it's pretty hard to read this formula, so I thought we would use an example just to kind of make it easier to kind of show where the data goes into the formula, right? So let's say in a given question we're using this data, right? So just these pieces. To solve the confidence interval for a given x, you'd use you'd use this formula, and this is how the data would be inputted. And then for a prediction interval, it's shown as this, right? And so to again make it easier, I just highlighted all the individual parts that would be needed for the confidence and prediction intervals, right? And so hopefully this kind of makes it easier to understand what goes where in this equation, right? And so yeah, you can, I don't know, take a screenshot, whatever, and yeah, in any case, each of these specific parts are highlighted to show, yeah, what goes where, right? And yeah, hopefully this makes the confidence and prediction interval question a bit easier to kind of understand and how to solve. Generally, you'll be rarely asked this question in a no data question, but yeah, in case you are, this is how you do it, right? And so yeah, that's pretty much part 6 in a nutshell. I will say that I did try to find if there was an R function that does solve the previous question right here for the confidence interval and the prediction interval, but I could not find it. So yeah, for now, to my knowledge, this is kind of the way to solve it. But if you do find another method, an easier method that doesn't force you to use all these pieces of data, then I'd advise you use that one because it's pretty easy to make mistakes with that equation. But yeah, that's pretty much it. We only have parts 7 and 8 to cover next, and they'll be using the ANOVA table, which we kind of saw in this part, but not that much. Yeah, I'll try to get those done soonish, but it's the second semester starting, and so who knows if I'm going to actually finish them on time, but I don't know. I've already made 6 videos, so I'll try doing it by at least the end of January, and if not, February. But yeah, anyways, peace.